Assalamualaikum warahmatullahi wabarakatuh. We are from Group 5. This is our group member Ahmad Iyad, Esma Azam, Lim Yun Xiang, Muhammad Firdaus, Nawawi, and Teng Kainan. About the problem we want to discuss is related to Lajat Laku product. Lajat Laku is a manufacturer that produces healthy supplement diet tablet called Lajat Guru. The observation taken 200 samples at random from 3 production shifts daily, namely morning, evening, and night, in December 2020 for different type of Lajat Guru tablet. For the part A, we summarize the sample data given of Lajat Laku tablet in the form of numerical, tabular, and graphical data so that we can easily to read the data given. First, we look at a numerical form. For the numerical form, we calculate the average and standard deviation of the weight, relative density, and the tensile strength. And for the tabular form, we calculate the average and the standard deviation of weight, relative density, and the tensile strength for each shift, which is morning, evening, and night. And we also calculate for the overall. For the graphical form, we can see that from the Lajat Laku tablet that produced in December 2020, it can be observed that the total number of sample size is 200, which is 65 for the morning shift, 72 for the evening shift, and 63 for night shift. Based on the average of weight per shift in December 2020, morning shift has the highest average production, while evening shift has the lowest average weight of production. Next, the morning shift has the highest average relative density with 88.278%, while evening shift has the lowest average relative density with 88.022%. The average tensile strength for night shift is 7.170 megapascal, which the highest average tensile strength, while evening shift has the lowest average tensile strength at 7.14583 megapascal. Now we look at for the part B. Question B. The Food and Drug Administration Authority required that weight of standard tablet produced by manufacturer should be normally distributed with 350 mg with standard deviation of 40. Comment on whether there is a significant evidence that Lajat Laku tablet produced in December 2020 regardless of shift do follow this distribution. For this problem, we solve using chi-square test. First of all, we make a hypothesis testing statement. We let X represent the weight, hash now X. Normally, 350 is the mean and 40 is a variance. And another alternative, X does not follow. Assume hash null is correct, Z equal to X minus 350 divided 40. So for the frequency table, we calculate the probability for each weight, which is we can get the probability on the statistical table using the Z equal to X minus 350 divided 40. And after that, we calculate the EI. EI is equal to N times probability for each weight. And after that we calculate the OI minus EI squared power of 2 divide the EI, and after that we sum for every value of the weight of this weight, and we get the X test. For the X test, we get the 30.1598, and we also calculate the X at the alpha equal to 0.05, and since X test is greater than X alpha 0.05, we reject the hash null. This means that hence there is no significant evidence that Lajat Laku tablets produced in December 2020 regardless of shift to follow this distribution. Now we look at for the part C. The part C, the question asks, they want to comment on whether there is any significant difference between tablet weight for the different shift. So first we make a hypothesis. H null is equal to mu 1 equal to mu 2 equal to mu 3. The equal mean weights between the shift. And for another hypothesis is mu r is not equal mu j. For at least one mean weight is different from the other shift. Therefore, there is a significant difference in between the shift. Okay. From the result above, the p-value is equal to 0.361281. Suppose we can choose alpha 0.05. Noticeably, the p-value larger than the alpha 0.05, thus we fail to reject hash null and conclude that there is no significant difference in weight between each different shift. The difference might due to certain random error. For the part D, based on the current data in December 2020, the prediction of the tensile strength of the tablet that has density value of 68%, 74.3%, and 80.1% are made by developing a linear equation between those two variables through linear regression. The test of validity of the developed model is done by doing the linearity testing with a novel approach and through correlation analysis. Microsoft Excel was used to analyze the given data and the output. The output are shown below. Based on the output above, the regression statistics give the information about the correlation coefficient which used in correlation analysis. The value of multiple R is the value of the coefficient. It is 0.8402, which is close to 1. The positive value and is close to unity show that the tensile strength of the tablet has strong positive relationship with its relative density. For the ANOVA testing, we made the null hypothesis beta is equal to 0 and another hypothesis is beta is not equal to 0. By using the given output above, it can be seen that the significant f is also the p-value. The p-value is very small. Even if the relationship is tested with 0.01 significance level alpha, the p-value will still be lower than the value of significant level. Since p-value is lower than the significance level, hence the hash null is rejected. Accepting hash alternative means that there is a linear relationship between tensile strength of a tablet and its relative density with slope measure. For the regression line of tensile strength versus relative density, based on the scattered plot above, it can be seen the equation of the regression line y equal to 0.0802x plus 0.0884 has a positive slope which agrees with the conclusion from the correlation analysis. It is also important to note that the y values are equal to tensile strength and the x value are equal to relative density. Hence, using the regression line, the prediction of the value of tensile strength can be calculated using the y equal to 0.0802 x plus 0.0884. So we just sub the value of the relative density at the x. So that's all from us. Thank you.